So good day everyone. So this will be the post-op discussion for Module 7. So this covers organic derivatives of water, carbonyl compounds, carbohydrates. Okay? So the learning outcomes of this module is for you to be acquainted with the chemical properties of organic derivatives of water. So these are your alcohols, phenols, and ethers. Okay? Then we have your carbonyl compounds, which are your aldehydes and ketones, and your carbohydrates. Okay? So you have your monosaccharides, disaccharides, and polysaccharides. So next is for you to observe the differences in chemical reactivity of primary, secondary, tertiary alcohols, phenols, and ethers towards selected chemical reagents. Then observe differences in chemical reactivity of aldehydes and ketones. And lastly, perform chemical tests that characterize the different types of carbohydrates. So yung ating organic derivatives of water is your alcohol, phenol, and ether. So why is it called again as derivative of water? So basically we have water. So naging derivative siya of water because nare-replace natin yung hydrogen attached to your water. So in alcohol, pinalitan natin siya ng R group. That's why it became alcohol. For phenol, it became phenol because we have attached an aryl group in your instead of hydrogen. And for ether, we have attached two different or same R groups in replacement to your two hydrogens attached in your water. So now let's proceed first to your alcohol. So your alcohol has a functional group of hydroxyl group. So your hydroxyl group are your OH groups. So this can be primary, secondary, or tertiary alcohol. So ang ating primary alcohol is yung ating alcohol is attached to a carbon na naka-attach, or your primary alcohol has a hydroxyl group attached to a carbon atom with another carbon atom attached to it. So basically, yung ating primary alcohol is ito. Yan ay R. Okay? So sa secondary naman, same nito, pero dalawang R na yung nakadikit. Okay? Then sa tertiary naman, tatlong R na yung nakakabit. Okay? So yung sa secondary, yung dalawang R na tinutukoy natin is ito. Then sa tertiary, ito, tatlong R na yung naka-attach sa ating carbon, directly attached to your hydroxyl group. So yung pagka-classify natin ng primary, secondary, and tertiary is important because they have different reaction towards several reagents. So we can differentiate primary from secondary because sometimes primary reacts to certain reagent, secondary alcohol does not react. Mga ganong tipo, okay? So in here, we can also have a hydroxyl group attached to an aryl group. So these are your phenols. And the pKa is 9.9. So basically, they are more acidic than alcohol. Kasi ang pKa ng alcohol is 17. So ang water naman, ang pKa ng water is 15.7. So in nature, acidic siya. Okay? So the acidity is primarily due to the resonance stabilization of the negative charge in the phenoxide ion. So as you can see here, if your phenol is in the presence of a base, since this is an acid, so it forms your phenoxide ion and your water. And your phenoxide ion results from the deprotonation of the OH group by a strong base. Okay, so this is a strong base. So what are your strong base? So these are learned from your basic or Chem 18. So these are your NaOH, KOH, LiOH, calcium hydroxide. So these are your strong bases. So next is your ethers. So ethers has a ether group or alkoxy group functional group. So ROR ito. Okay? So hindi pwedeng RRO. So bawal 'yon. So kung paano sila nagbabond with each other, since ang O is nakaband kay R and ang O pa ulit ay nakaband sa isa pang R. So ganito natin siya isusulat. So not this way. Okay, malito. So in here we have no exchangeable proton. So this makes this ROR least reactive organic derivative of water. So medyo inert tong ating ether. That's why we sometimes make this as solvent, parang yung dichloromethane natin. Diba laging siya nakikita as solvent. So yung ether, ginagamit din natin siyang solvent kasi nga medyo inert or hindi nag-react itong ating ether. So this is an example of ether. So we have your diethyl ether. So meron kang dalawang ethyl na naka-attach sa O. That's why it became diethyl ether. So in here we have ethyl, methyl, ether. Okay? So after the organic derivatives of water, we now proceed to the carbonyl compounds. So your carbonyl compounds are either aldehydes or ketones. So these are aldehydes. So yung aldehyde natin is ganito yung itsura. We have your carbon, double bond O, and then H, and an R group bonded to your carbonyl carbon. So this is your carbonyl carbon. Kapag naman ketone, yung H sa aldehyde natin, papalitan lang natin ng isa pang R group. Okay? So as you can see here, there is a difference in polarity. So basically, mas electron rich yung ating oxygen na part and electron deficient yung ating carbon. That's why we have here a highly polarized carbonyl group. And due to this, this is now making it susceptible to electrophilic attack. While yung carbon natin is susceptible to nucleophilic attack. Okay? Ang last na organic compound or class of organic compound that we will discuss is your carbohydrates. So your carbohydrates are basically aldehydes and ketones, pero sila ay polyhydroxylated, meaning marami kayong hydroxyl groups attached to your aldehyde and ketones. Okay? So the general functional group of this is OH and carbonyl group. So dalawa yung functional group na pwedeng present sa ating carbohydrates. So this can be classified as aldose kung yung carbonyl group na naka-present dito is an aldehyde, or it can be a ketose kung ketone naman yung carbonyl group na naka-attach sa ating carbohydrate. So ito yung sinasabi natin na polyhydroxylated aldehyde or ketone. So maraming hydroxyl group, then meron kang aldehyde. So basically this whole compound is an aldose. Then ito naman, this makes it a carbohydrate since this is polyhydroxylated. And this has a carbonyl group in the form of ketone. So basically, we can classify this as ketose. Okay? So there are several classification depending on the number of carbon atoms. So kung tatlo yung carbon atom present, it can be triose. Kung apat, tetrose. Kung pito, heptose. So these are an example of those. So ang ating glucose ay aldohexose. Ang fructose natin ay ketohexose. So you see here, aldo meaning aldehyde group yung carbonyl group present sa ating glucose. Then sa fructose naman ay ketone group. Okay? So as you can see here, parehas na aldohexose ang glucose and galactose. Pero iba lang yung arrangement natin or orientation of polyhydroxylated group. So in Chem 160, sinasa ulo to. Kung saan nakalagay si hydroxyl group, it can either be glucose, mannose, galactose, and so on. So yung carbohydrates natin, it can either be in an open chain or cyclic form. So yung open chain natin can be illustrated using Fisher projection. So yung ating Fisher projection, ito yon. Kung paano natin siya sinulat, yung parang tinik. Yan. So OH, 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 then diCH2OH. Ito yung ating Fisher projection. Meron pang isa, we have our Haworth formula. So ito yung kapag naging cyclic form na siya. So dito meron tayong alpha anomer and beta anomer. So yung anomer natin is yung anomeric carbon, which is your carbon 1. Siya yung nag-connect dun sa ating oxygen or yung oxygen na nandito. And it can be termed as alpha if your hydrogen is oriented to the top position or sa taas. Kapag naman beta, yung hydrogen sa anomeric carbon is oriented downwards. So yung ating 1 is your anomeric carbon. And the orientation of hydrogen signifies if it is an alpha or beta anomer. So, meron pa tayong isang illustration. It can be in a chair or boat conformation. So, ito ay natutunan nyo na sa stereochem, diba? Sa module 5. So, itong chair conformation natin, so ito ay nagiging alpha, again, if naka-orient pataas yung H, and beta kapag naka-orient pababa yung H. Then, yung ating carbohydrates can be a reducing sugar. Ang reducing sugar natin, it just means that it is an oxidizable, and magiging oxidizable lang siya if it has a free anomeric carbon. Otherwise, this becomes non-reducing sugar kung walang free anomeric carbon present dun sa ating carbohydrate. For example here, since this is our anomeric carbon, so dito, naging OH siya. So, it means that this is a free anomeric carbon. Sabi na, ang dulo niya, OH. Pero, if we have a carbohydrate wherein this glucose is attached to another R group, so ibig sabihin hindi ito free. Hence, this is considered as non-reducing sugar. So we have our major classification as mentioned sa ating learning outcomes. We have monosaccharides, disaccharides, and polysaccharides. So basically, nagpo-form yung disaccharides and polysaccharides by virtue of glycosidic bonds between two monosaccharide units. So ito yung ating glycosidic bond na tinatawag. Okay? So for polysaccharides, ito yon. Kung paano nagli-link yung ating dalawang or pinaka-simplest unit natin, which is your monosaccharide. Then for the experiment, these are the samples used. You have your 1-butanol, 2-butanol, tert-butyl alcohol, and phenol and diisopropyl ether. Then for carbonyl compounds, you have your benzaldehyde, acetone, and cyclohexanone. And for monosaccharides, you have your glucose and fructose. And for disaccharides, you have your lactose and sucrose. So, solubility tests were done. So, kapag nag-form ng 2 layers, ibig sabihin negative yon. Kapag nag-form ng uniform solution, ibig sabihin positive yon. Ibig sabihin soluble sila. So, this must be included in your result. Okay? So, dito sa 2-butanol, in water and NaOH, medyo hindi distinct yung layer, di ba? Unlike dito. That's why it can be medyo vague yung ating result. Kasi basically, yung ating alcohol is partially soluble in water. But not completely. Okay? That's why medyo positive siya dito. Yung secondary secondary alcohol yung tinutukoy ko. Okay? So, the solubility test. So, in here, we have your 2-butanol. Intermediate siya. That's why it became slightly soluble in water. And your concentrated sulfuric acid is so powerful that all oxygen atoms in an organic sample is protonated. Okay? So, for the phenols naman, so these are sparingly soluble in water due to the large aromatic ring. And phenols become less soluble in water as more alkyl or aryl groups are attached to the phenol ring. So, kaya siya nagiging sparingly soluble is because of the formation of the phenoxide ion. Okay? So, how about the solubility test for carbonyl? Okay? So, yung starch, medyo turbid kasi siya, kaya positive or negative. Para sa benzaldehyde, kita natin na may 2 layers. And sa acetone and glucose, kita natin na miscible talaga sila. Then, for permanganate test, what happens here is, dapat makakita tayo ng formation ng precipitate. Okay? So, in here, the permanganate test involves the hot acidic potassium permanganate solution as the reagent. And the positive sign is the disappearance of purple color and the formation of brown precipitate. And this is only positive for primary and secondary alcohols as well as phenols. Okay? So, yung tert natin and the isopropyl ether is negative for permanganate test. So, as you can see here, the permanganate ion is a strong oxidizing agent, and the alcohols that will positive test are those that have at least one hydrogen attached to the hydroxyl-bearing carbon. So, ang essence nito is dapat yung carbon natin na may hawak ng hydroxyl group should have at least one hydrogen for it to become positive for permanganate test. So, this applies to alcohols. That's why your tertiary alcohol, since wala siyang free hydrogen attached to the carbon with the hydroxyl group, so no reaction ang nakita natin sa tertiary alcohol. For phenols naman, the reaction involves due to the resonance stabilization of phenoxide ion. So, ito yung nagiging ating reaction. So, the formation of this compound and the formation of MnO2 states the positive test for permanganate of your phenols. And yung ether natin ay negative pa rin for your KMNO4. Next natin is your Lucas test. Sorry. So, yung Lucas test natin is medyo nag-iintay tayo dito. Kasi medyo slow ang reaction niya with primary and secondary. Pero mabilis yung reaction niya with tertiary alcohol. Pero you can consider it as negative test for primary alcohol. Okay? So, in here, the reagent used is HCl. And the purpose of HCl is to protonate the hydroxyl group to become a better living group as water. And the zinc chloride here is acting as a Lewis acid catalyst. And the positive sign is the formation of turbidity of the solution or mixture, meaning nagiging cloudy yung ating appearance. And as mentioned here, the positive test is done if the sample is a tertiary or secondary alcohol. So the rate of reaction here can be observed na mabilis sa tert butyl alcohol compared kay secondary alcohol. And this is due to the order of stabilization. The tertiary alcohol is more stable compared, or the carbocat ion, the tertiary carbocat ion is the most stable one compared to the methyl carbocat ion. So these carbocat ion are produced since the OH group became OH2. And the OH2 is a better living group. So, kapag umalis na yung OH2 na naka-attach sa carbon na to, magiging positive yung ating carbon dito. And since this is positive, this is generally termed as carbocat ion. And this carbocat ion has several stability. Mas stable yung tertiary carbocat ion. Followed by benzylic, followed by allylic, followed by primary. Yung allylic at secondary, medyo same sila na level. Followed by vinylic, and then lastly, your methyl. So, the stability is due to the hyperconjugation and resonance effects in our carbocat ion. Okay? Since ang ating primary carbocation are very unstable, so it is safe to assume that there is no reaction with primary alcohol with Lucas reagent. So the next test is we have our ferric chloride test. So ang ferric chloride natin is test for phenols. So the color of the complex changes depending on the identity of the phenol. Pero ang malinaw dito is merong change of color from clear naging ganito. Okay? So this is a qualitative and quantitative analysis of phenolic compounds. Kasi may mga compounds na maraming phenols. So if you want to know if you have phenol here present in your compound, you may use ferric chloride test. kahit konting amount lang ng sample, so imimix mo lang siya with ferric chloride. So, if there is formation of blue, purple, or red complex, so sure ka na meron kang phenol present in your compound. Next is we have our tolerance test. So, tolerance test is a test for aldehyde. Okay? So, ang positive sign niya is the formation of silver mirror or gray deposition in your test tube. Okay? So, yung silver mirror na yun ay due to the silver solid produced there. Okay? So, basically, kapag nasa lab, sobrang nagtitipid tayo sa tolerance reagent. Kasi mahal. Mahal ito because meron kang silver. Kaya minsan, instead na individual works ito, one test tube lang for the whole class ang ginagawa natin dito. So, papakita lang natin yung reaction ng benzaldehyde with tolerance reagent. Then, makikita ng buong klase na merong formation of silver mirror dun sa ating test tube. Yung ibang test na ginawa natin, pwede siyang gawin by group or individual. Kasi mura lang naman yung ibang solvent na ginagamit or reagent na ginagamit natin. Pero for this tolerance reagent, medyo pricey or expensive yung ating sample or reagent. That's why medyo nagtitipid tayo dito because it is silver. Okay? So next is we have your iodoform test. So ang iodoform natin is the formation of yellow precipitate. So this yellow precipitate is due to the presence of alpha methyl ketones. And also, it may test positive for methyl carbonyls. Okay? So what happens here is, so alpha methyl ketones, so ito yung ating methyl ketone, further reaction produces your iodoform. Okay? And this iodoform is yellow precipitate in color. Okay? So, ang ating 2-butanol is a methyl carbonyl. Also with acetone. Okay, next natin is 2,4-DNP test or your 2,4-dinitro phenylhydrazine test. So, this is a general test for carbonyl or carbonyl groups. So, kung meron ka aldehyde or ketone, magpa-positive ka dito. So, what happens here is, nagkakaroon ka ng formation of yellow to orange precipitate. And this is due to the formation of hydrazone. Okay? So, for the test of carbohydrates naman, we have our Molish test. So, ang positive test natin ay yung sa mga carbohydrates natin. Oh. Kita natin yan. So, kapag carbohydrate yan, magpa-positive yan sa Molish test. And the positive result is evident by the formation of purple or red-purple interface. Okay? So, yung formation na yon ay kino-convert natin yung ating sugar to hydroxymethylfurfural. And yun yung ating purple color na nakikita natin. Okay? Then, lastly, we have our Benedict's test. So, ang Benedict's test ay test for reducing sugar. So, what happens here is, from blue, nagiginto yung kulay nila. So, nagiging kulay yan kapag meron kang reducing sugar present in your solution. So, yung hydrolysate natin is just the product of the hydrolysis of disaccharide and polysaccharide. by hydrolysis meaning kinlive natin yung sucrose natin into its monosaccharide intermediate or component. Okay? So what happens here is your copper 2 plus ion, citrate, and carbonate salts are the reagent involved in this Benedict's test. And the positive sign is the reaction of or the formation of yellow-orange to brick red precipitate. So basically, yung mga reducing sugar in the form of glucose, fructose, lactose, and the hydrolysates of this one are your reducing sugar. So yung ating glucose, it easily reacts with Benedict's reagent. However, fructose is not an aldose. So in order for it to react, it must be transformed from its ketose to its aldose form. So, medyo mahirap because nagkakaroon pa ng isomerization. And isomerization requires alkaline condition. So, kailangan basic yung ating solution. So, ito, additional information na lang to para sa inyo. So, ang pinaka-importante lang na malaman nyo dito is ang Benedict's test ay test for reducing sugar. Okay? So, na ating Benedict's test ay nagre-react lamang sa linear aldose form ng sugar. So, kapag yung ating naka-chain na sugar ay hindi kaya mag-form ng linear form, so hindi siya nagpo-proceed sa reaction with Benedict's test. So, nagkakaroon ng no reaction. So, ang reducing sugar natin is, again, kapag meron kang free anomeric carbon. So, kapag free yung anomeric carbon, nagkakaroon ng reaction with Benedict's test. So, yun dito, we have your lactose. Your lactose is composed of galactose and glucose. So, the anomeric carbon of the glucose unit is not involved in the glycosidic bond. Hence, it is able to revert back to its linear form. So, ito yun. Ibig sabihin, this is now your reducing sugar. Since meron kang free anomeric carbon. For sucrose naman, sucrose is composed of fructose and glucose. And based from the attachment of the glycosidic bond, there will be no free anomeric carbon. Kasi both anomeric carbons are involved in the glycosidic bond. So, since walang free anomeric carbon, sucrose is considered as non-reducing sugar. So, sa experiment natin, sucrose, starch, and cellulose were hydrolyzed. So, yung product ng hydrolysis ng ating sucrose, starch, and cellulose are generally termed as hydrolysate. Okay? And these hydrolysates were subjected to Benedict's test, and from the result, the reducing sugar were detected after mild acid treatment of sucrose and starch, but not for cellulose. Okay? Sa sucrose kasi, pag nag-hydrolysis ka, makikita mo na magkakaroon ka ng glucose. And glucose is a reducing sugar. Okay? Ang starch naman, kapag nagkaroon ka ng acid hydrolysis, you'll have your glucose units. So basically, glucose are reducing sugar. That's why it will become positive for Benedict's test. For cellulose naman, cellulose is a resistant to mild acid hydrolysis because of the beta-1,4 glycosidic linkages. So, ito yung ating beta-1,4. Ito yung 1, Ito yung 4. And this type of linkage is most hidden between the sugar cycles. And through that, hindi madaling ma-cleave yung itong bond na to. That's why there is no reaction upon acid hydrolysis. Kaya wala kayong hydrolysate for cellulose. So for sample problems, ano kaya yung chemical test that we can differentiate compound 1 from compound 2? So the answer here is iodoform test, since ang ating compound 1 will react with iodoform. Since ito ay methyl carbinol. Okay? For number 2 naman, hindi siya mag-react with iodoform since hindi siya methyl carbinol or methyl ketone. Pero, pwede kang mag-employ ng 2,4-DNP test since 2,4-DNP test is general test for carbonyl groups. And since compound 2 is a ketone, while compound 1 is an alcohol, so magka-positive yung ating compound 2 for 2,4-DNP test. So, how about compounds 1 and 2? So, ang sagot dito is tolerance test for compound 2 because tolerance test is a positive test for aldehyde. So, aldehyde ito. Or 2,4-DNP test since we have here an aldehyde or carbonyl to. Ito kasi ay carboxylic acid. Okay? Ito ay aldehyde. So, 2,4-DNP test is a general test for carbonyl groups. Next is we have compound 1 and compound 2. So, ang sagot dito is 2,4-DNP test ulit since ito ay carbonyl, ito ay hindi carbonyl. This is an ester. Next is compound 1 and compound 2. So, both are carbonyl. Ito ay aldehyde. Ito ay ketone. So, pwedeng tolerance test because this will have a positive test for aldehyde. And pwede ring iodoform since iodoform is positive test for methyl ketone. So, how about this one? So, ito ay aldehyde and an alcohol. Ito ay aldehyde pero polyhydroxylated. So, pwede itong Molish test because mag-react dito yung carbohydrate natin. Ito, this is not considered as a carbohydrate because hindi naman siya polyhydroxylated. So, next, compound 1 and compound 2. Ito ay alcohol. Ito ay ether. So, ang ating test is ferric chloride test. Sorry, hindi pala ito alcohol. This is phenol. Sorry. So, this is phenol. So, this will have a positive test with ferric chloride. So, yun. Common mistake yun. Okay? So, how about the next set of or pair of compound? We have here a primary alcohol and a tertiary alcohol. So, pwedeng Lucas test since compound 2 will react. So, mabilis yung reaction natin dito. Kasi tertiary ito. Or pwede ring hot acidic KMNO4. So, ang mag-react lang kasi sa KMNO4 is primary and secondary lang, di ba? So, basically, your primary alcohol will react with hot acidic potassium permanganate. So, these. So, pwede tayong mahuli ulit like the common mistake that I have earlier. So, this is a phenol and this is an alcohol. So, what you can do is ferric chloride test kasi magpa-positive siya sa phenol. Or pwedeng Lucas test since magpa-positive siya sa secondary alcohol. Next, we have here tertiary alcohol and an ether. So, pwede ditong hot acidic KMNO4. So, compound 1 will react. Tas dito, Lucas test will react with compound 1 since this is a tertiary alcohol. Okay? Yung ether kasi no reaction yan. Kasi nga, di ba, inert yan. So, how about this one? We have your, medyo ito ay carbonyl and secondary alcohol. So, pare-pares naman silang secondary. So, ang test natin is iodoform. Since sa compound 1, nag-react siya with carbonyl compounds. So, basically, this is your summary. So, balikan lang natin yung isa. Medyo, eto. So, paki-disregard ito. Disregard to. Only Lucas test is applicable for this sample problem. Kasi ang KMNO4 ay hindi nag-react with tertiary alcohol. Okay? So, yan. So, Lucas test lang yung applicable dun sa na-mention natin kanina sample problem. So, these are the summary for your module 7. So, you have your hot acidic KMNO4. This is positive test for primary and secondary alcohol. For Lucas test, secondary and tertiary. For iodoform, for methyl carbonyls and ethanol. For ferric chloride test, these are general tests for phenols. For Tollens test, this is general test for aldehydes. For DNP test, this is a general test for carbonyl groups, particularly aldehydes or ketones. Molish test ay general test for carbohydrates, and Benedict's test is general test for reducing sugar. So, yung reducing sugar natin is dictated if meron kang free anomeric carbon present in your carbohydrate. Okay? And you should take note of the visual result, which is expected as you have your positive test of these simple chemical tests. Okay? So, I think this ends the presentation for the Postlab discussion of Module 7. So, I will end the discussion now, and thank you for listening.